We have this contrived looking exponential equation here with a very strange looking exponent right here. Now this exponent actually is quite useful in terms of where we start our search. So we can see clearly that x has to be a member, and I'm going to use the closed open. This means 27 over 7 is a possibility. And then we put comma infinity. And of course, infinity is not a number. It represents unboundedness in the positive direction. So we have to use a parentheses instead of a square bracket right here. Okay, a little technicality. So x has to be in this interval if there are any solutions. So a priori, you wouldn't know if there are any solutions. Now, some of you may have already be saying, well, this is an increasing function. This is a decreasing function. That's good because if we find a solution, it'll be unique. Okay, this is definitely a decreasing function right here. Now, on the right-hand side. So let's move along and see how and by the way, we were given that x is a rational number too. That's useful. You know a little bit more. It can't be an irrational solution. Or it could be, I suppose, but we're given that there is a rational solution. Okay, let's move along. And I'm just repeating what I said right up here. Okay. It's clear that x minus 27 over 7 has to be greater than or equal to 0. So it's very natural to start with x equals 27 and see what it produces. Now notice that 27 over 7 minus 13 over 7 is 14 over 7, which is where you get this 2 right here. Let me just, rather than clutter it too much, this comes from 14 over 7. Okay, the base is 14 over 7. That is when you put 27 over 7 right here, 27 minus 13 is certainly 14, and divide by 7 gives you the 2 you see here. In a similar fashion, this part becomes 0, so that's where this 4 you see here is this 4 right here. Now it's very easy to see that this is, I say it's very easy, actually it takes a little bit of time. At the beginning of the problem, it may be useful to note that this is certainly divisible by 2. All right, now I won't go through all the calculation on this, but this happens to be 2 times, and you can see it's divisible by 3 because the digits sum up 8, 10, 18. 18 is divisible by 3. It turns out it's 3 to the 5th though. Okay, and y'all, I'm not claiming this is easy. You would have to do this on your own time without a calculator since it's a competition problem. Okay, and then 17 is the other number. So again, this would be probably the time-consuming computational aspect of the problem. Okay, but you can see why this is not equal because this would be this is equal to 16 right here, and this number would be what do we have? 3 to the 5th. This would be equal to, okay, y'all, the 7 cancels. You have 3 cubed. So this would be equal to 2 times 3 squared is what I'm getting, folks, times 17. Okay, so that's why this is not equal, right, folks? Again, I just did 7 over 7 cancels. This is 3 cubed. That's going to leave 3 squared here. Okay, so you can see why this is not equal. So that was a try, but it doesn't get the job done. Okay, now let's take a look at the next try. Now the next try, you want to keep trying with integers because this seems to be a contrived problem where you're probably going to have integer exponents. You know, that's not guaranteed. You could have rational exponents. But so 34 is the next natural try because 34 minus 13 over 7 is equal to 3, right, folks? That's 21 over 7, so that's equal to 3. And of course, a similar fashion, right? You put 34 minus 27 over 7, that's just 1. Square root of 1 is 1, so that's where the 3 to the 5th comes from. Now let's check and see what's going on here. And let's just write down our number 2. And I'm just writing it down here as comparison, 2 times 3 to the 5th. You can see that it's already working, right, folks? So that's the top part. Now the bottom part is just going to be 34 over 7, and that cancels, right? So here you get 34. Right, folks? And again, I left out just a little bit, but in other words, if you put 34 over 7 where x is, all that's left is 34, right? And so you can see that this is 2 times 17 is 34, so this does equal to 3 to the 5th. Okay. So this checks. Let me just circle this. Okay, they're equal to each other, right? Okay, so I can just put equals here, I guess, right now that we've done it. But anyway, folks, that's it. And like I said earlier, this function is definitely a decreasing function as x gets larger, right? As x gets larger, this function is getting smaller and smaller and smaller. X will overwhelm even this constant right here. And this exponential function is certainly increasing. So this is the only solution. 3 to the 5th is a unique solution. Okay. Excuse me, x equals 34 over 7 is our answer. Okay, sorry about that. X is equal to 34 over 7. Okay, let's place it right next to this aerial view of an octopus. X is equal to juggling nonetheless.